welcome to this explanation of a 3x2 digital memory circuit. This circuit stores 2-bit words at 3 different addresses, A1, A2, and A3. This is not flash memory, which means that when power is cut, all data is lost. The circuit is fairly simple in design. It only has 10 ICs, 5 switches, and 2 LEDs. As I said earlier, it stores 2-bit words in 3 different addresses. These addresses are decided by 2 inputs, A0 and A1. As well, the data inputs are decided by D0 and D1, and the read and write inputs are decided by a single switch. When the read and write switch is at 1, the circuit will read the data. When the read and write switch is at 0, the circuit will write data. As well, there are 2 outputs, Q0 and Q1. Q0 is the sum, and Q1 is the carry. These are the address inputs, A0 and A1. As you can see, they are connected to both ground and power. These are the data inputs, read and write inputs, and the outputs. You can see right here, this is Q0 and this is Q1. Remember to put a resistor. Okay, so this is a circuit diagram for the circuit that I was just talking about. As you can see, here's the read and write input that I was talking about, the A0 and A1 inputs that I was talking about, and the D0 and D1 inputs that I was talking about. As well, here is Q0 and Q1. It's important to note that the flip-flops must be set to run in both asynchronous mode and to be triggered on a positive edge. Asynchronous mode means that the flip-flops run independent of the clock, and being triggered on a positive edge means that when the read-write switch is low, they will be written to. And being triggered on a positive edge means that when the read-write switch is low, the flip-flops will be written to. Let's take an in-depth look at the read and write switch. When the read and write switch is at 1, like it is right now, as you can see, it goes through the inverter, which means that the clock for each one of these flip-flops is at 0. Because the clock is at 0, it makes the flip-flop output its saved value. The output value then goes through these set of gates and comes out of the output. However, when the read and write switch is at 0, like it is now, you can see that it goes through the inverter to become a 1, and whichever address is chosen, it will turn those clocks into 1s. Because we have set these flip-flops to trigger on a positive edge, whatever value these flip-flops have stored in them will be outputted. There are 3 possible addresses that can be accessed in the circuit. A1, where A0 is set as 1, A2, where A1 is set as 1 and A0 is set as 0, and A3, where A1 and A0 are both 1. Of course, there's no address 0, so A1 and A0 being 0 at the same time is not allowed. As for the data inputs, for D1 and D0, there are 4 possible combinations. The first one is 0, 0, the next one is 0, 1, the next one after that is 1, 0, and the final one is 1, 1. So now that we know how the circuit works, let's see it in action. Okay, so as you can see, this is a circuit fully built. Here we've got D0, D1, A0, A1, and the read and write switch right here. Let's zoom in a little so you can see that better. Alright, read and write switch right here. So to prove that it works, let's go to address 1, and we will write 1. Alright, this is a read and write switch, so right now I have the data in set to 1, 0 or 0, 1. I hit write, I hit read again, there we go. Now it's changed to 1. This is Q0, this is Q1, this is sum, this is carry. Alright, so now for address 2, let's write 2. Alright, change that to 2, now hit write, read, there we go, now it's 2. Alright, finally, let's do, for address 3, let's write 3. Both of these are turned to 1. I hit write, I hit read, there we go, it works. Now what happens if I turn it off, on, okay, well the data should be wiped, and I'm sure it is in, in other addresses. This is address 1, we wrote 1, but now you can see it's 3. This is address 2, we wrote 1, but now you can see it's also 3. So after power is removed, the data is lost. Alright, that's about it. I hope that helped. Thanks for watching. See you!